Okay, hello. Yeah, I'm going to write to a factorial. Let's just use the base side. Just a little funny thing. So, hello, Lean. You read the description. I'm going to write a factorial. I won't bother with extreme large integers. Let's just use unsigned long. Okay, bit sore throat. Very little bit. Let's calculate factorial of 10. That fits in this unsigned long, right? Yeah, easily. Why is this indented? Oh, this wants to indent 4 spaces. Okay, how to write a factorial only using addition. Aha. Well, we got it here. So I would say that n factorial, like say this is 2 factorial, 3, 4, 5 factorial, is in the column after the 10, where the 10 is the sum of 4 plus 3 plus 2 plus 1. So 1 plus 2 is 3 plus 3, yeah. Let's add a formula for that. Well, usual trick, that is n plus 1 times n divided by 2. It is direct. Well, n times that, sorry. Yeah, well, n times n plus 1 divided by 2. So if we fill in 4, that should be 10. 4 plus 1 is 5 times 4, 20 divided by 2 is 10. So now we have the y column, the x column I mean. Says 20 is 5 factorial here is column 11. Let's just use the top row here as x. And then how far down? Well, every time the new factorial is just one row down. So this is 5 factorial. Let's also call this 1, whatever. 1, 2, 3, 4, 5. So x comma y is then a return. Let's call it Mussner. The sum of n plus 1, comma n. AA4 I just felt like writing that function that I asked ChatGPT, which is completely 100% filled on. Big int listener taking a big int, comma int n. It's kind of silly to use a big int for the x value, I think, because that's no, yeah. I mean, it's the square of around the square of what you want to calculate the factorial of. It's not really a big int, is it? Let's just keep using an int here. Which means that this is an int, and I'm gonna call that x, and this is well, it's whatever. So we're still at integers here. Okay, so then we want to return here. Oh no, I did use a multiplication here, by the way, but yeah, I mean, if say you want to print out all factorials and just keep printing every time the next factorial, next factorial, next factorial, then maybe it would be more efficient to only do additions. But I want to print factorial of whatever number I give directly, or at least now forget not using multiplication. I just want to use the Musnov trick. So I have now the xy coordinate, right? So we want, say, 5 factorial. We want to print this number. Nah, it's slightly. The problem here is that this number is equal to that number. How do we detect that? Let me explain how this works. This is 1, 2, 3, 4, 5, 6. You already probably saw that. This 2 is a copy of that number. Maybe we can. Okay. Let me first explain where this 6 comes from. 6 is the sum of this 2 and this 4. Yeah. The 11 is 5 plus 6. The 18 is 7 plus 11. 26, 8 plus 18, so the 15 is 26 plus 24, and so on. So we just simply add up what is to the right and what is directly above it. And then you have all the factorial numbers here in the end. However, well, if you want to calculate this number, you just what I'm making here is a function that should return the number at position x, y. So if you want to calculate, say, this 50, then you just simply add the number directly above it, which is a y coordinate 1 less, plus the number directly to the left. But if you want to calculate 24, you have to go like all the way there. And the 18 also skips a bit, so it is 600. How do we know that we have to subtract 1, 2, 3, 4 from this 600? Well, we have to subtract 1, 2, 3, 4 here. We have to subtract 1, 2, 3 here. We have to subtract 1, 2 here. And this happens to be column y coordinate 2. So we just have to subtract y. But only when we are in the column that we just calculated. So only if we are in a column, only when we are in the column 2, 4, 7, 11 and so on. So how can we detect that a given number is exactly in that column? So I want 10 to go to 7, and 9 and 8 as well. Where 7 is just one more than 6. So I might as well go from 10 to 6. I guess it's the reverse of the function that I just had, and then -1, and then the function again. And then round it off. Ish. Close to. So this function, I need the inverse of this function. Well, that's not too hard. You multiply by 2. And then, whoops. Now we have to solve a quadratic equation. Seriously? Let's call this something else. Let's call it S, the S of sum. So the sum is n times n plus 1 divided by 2. From which follows that 2s equals n squared plus n. From which follows that n squared plus n minus 2s equals 0. From which follows that n is something divided by 2. And that something is, oh boy, I should know that from my head. Isn't it like minus b squared? What it was a minus. So b here is 1, so it would be -1, I guess. We can just check it. Plus or minus the square root of no, this is a b squared. I think it's minus b with them. It's also 1 anyway. I think this is b squared minus 4ac. So that is plus 8s. I'm just guessing here. It's really, really bad. Okay, so if S is 10, that's 81, that's 9. So this must be a plus. 9 minus 4 is 8, divided by 2 is 4. Yeah, that's correct. So I guess it works, right? Or shall we check it for one more number? So the sum of 1 plus 2 plus 3 all the way up to, let's say, 7 is 7 plus 1 is 8, divided by 2 is 4, times 7 is 28. 28 times 8. Okay, now I cannot no longer do it from my head, at least I'm too lazy. 27 times 8, right? Plus 1 square root. That's not even an integer anymore. Something is wrong. So I'll start over here. 7. 7 times 8 divided by 2 is 28, not 27. 28 times 8 plus 1, 225. Square root is 15, minus 1 is 14, divided by 2, 7. Yeah, that works. Return, yeah, now we even have square roots. What the? That was not the idea. Okay, who cares? Square root of 8 times s plus 1 minus 1 divided by 2. Okay, now this is just an approximation, because I mean approximation, it works for the exact sums, but what does it output for other values? So let's start to investigate that first. I'm just going to run over, and it's 1, 2, oh, how far do we go here, because I'm lazy again, all the way up till 16, okay. Then it's less than or equals 16 plus plus n. And I'm going to print, well, let's say you print n and a colon, and then the sum inverse. Well, that's nonsense. I meant we go all the way up till, no, that's correct. Sum inverse of n. Huh? What? 23. Oh. $27. Unused code. Let's print this whole table because I don't want to switch back and forward. Okay, can set the width one more, one higher. I want to mark every column that is let's say we just mark these numbers 10, 15, 5. Those are triangle numbers then. Yeah. Must be an easy way to detect if the number is a triangle number, no? I don't think. Not really. I mean, you have to check that if you multiply it by 8 and add 1, if that's a square. I guess. Okay, how can we find out quickly if a number is a square? There must be an answer for that. Take the root of the integer. Is there no easier way? Apparently not. Everyone is taking the root. Everyone is taking the root. I guess I really should include CMath for the root, even though it already compiled. This prints an exclamation mark before 10, but not the way I wanted it. And it prints an exclamation mark after the 5. But what? I probably should just put it behind it. Okay, so 15 and 10 and 6 and 3. 6, 10, 15. Yeah. And then something went wrong because now I have the width here. I want to, I don't know. I want to have it in front of it. Ugh. Stupid thing. That's better. Okay, triangle numbers now have an exclamation mark behind it, and this is what my some inverse is being returning. So below the exclamation mark we see a 5 here because that's not true. That is true. It computes to the 10. So 1 plus 2 plus 3 plus 4 plus 5 is 15. 1 plus 2 plus 3 plus 4 is 10. So the sum from 1 till whatever's here is given there if there is an exclamation mark. Which means that all the numbers above it just give the number that is rounded down. And what I needed was now what I need is having 11, 12, 13 or 14. I want to find this column. And that's now, yeah, succeeding, I think. That is, they all go to 4, and then they go back to 10, and then I have to call. So we can print out sum, the sum of sum inverse. And then you see that 11, 12, 13 and 14 all point to that column. Now, the only thing I wanted to detect is if we are in this column. So what I should do is subtract 1 from x and then check if it is a triangle number. That's the only thing I want. Now, IT is triangle number, ITN. So what I want to return is, say, the 154 is the number above it plus a number to the left. But we don't have a number above it when we are at the top, which is y is 1. So if y equals 1, then the result is simply equal to x. If y equals 1, return x. If y is less than that, we return the number above it plus the number to the left. Except when there is no left anymore. Let's say if x is less than 3, then we return just x. Is that correct? You should only be needing the 2 here and the 1 maybe, but probably only the 2. Now we only need this 2 to calculate that one then. So here x is less than 3, therefore we can return 2. If x is less than 3, return x. Okay. Otherwise we return Müssen x comma y minus 1 plus theoretically müssen x minus 1 comma y, except when we are in this column, then I have to subtract from x the y coordinate. Y coordinate is 1, 2, 3, and we subtract 1, 2, 3 instead of subtracting 1. That means that if the minus 1 value is a triangle number. Yeah, so if x minus 1 is a triangle number, then we don't want to use x minus 1. So if it's a triangle number, we have to use x minus y, otherwise x minus 1. And now we're done. Methinks. Wait a minute. Oops. Redo. Undo. Let's print the first line anyway. Maybe print out the numbers at coordinates n and then y. So we don't want to do that. Let's do for y equals 2 less than or equal. That's too difficult. I'm just going to print it factorial. My undos didn't work. Didn't go as planned. Or redos rather. Yeah, and that looks like the factorial of 10. No, seriously, it does. 10 factorial. Where's my factorial on this calculator? There it is. Shift factorial. And it doesn't. Damn it, it's not good. 10 factorial is about 3.6 million. Let's use a smaller value. 5 factorial is 120. 5 factorial, let's calculate 5 factorial. Yeah, not good. Now then we are going to need debug output. Oh, making a lot of mistakes here. 3, 5. Why? Oh, lots of outputs. Right. So it tries to calculate the value of 16,5 4 factorial 5. Is that correct? No, it's not correct. 16,5, 1, 2, 3, 4, 5, that is 720. Not that it printed 720. But I tried to calculate 5 factorial. So we have one more than this, so I should subtract 1 from the end that I'm summing. Is that correct? No, that must be +1. Sorry, this must be n minus 1. Not that we are trying to do that, but seriously, that's the same errors I had before, and I fixed it. And now we are back there. Why? I just undid my changes. That is really weird. I know this is red for some reason. It's a quote here. Okay, 5 factorial is Mushner 11,5. 11, 1, 2, 3, 4, 5. Yay! Oh, I see the error, yeah. The error is that this number is equal to the number above it. And the reason is that the reason that we are so far down that there's nothing to the left. Okay, how do I detect that? Do I calculate a triangle number of... Yeah, I think I do. Right? No, I subtract 1 and then I calculate a triangle number. So if it is a triangle number, then I rather would want to know what the sum is then. So what leads up to the sum. So in this case it would be 4. And then we can add 1 again to get 5. 1, 2, 3, 4, 5. Let's save the optimization for later. If it is a triangle number, then there's another check that I have to do. If it's a triangle number, I just want to know what that is. I didn't use n yet. It's a sum inverse, right? So sum inverse of x minus 1. I think x is 11, minus 1 is 10, sum inverse is 4. And then if y equals to that number plus 1, or it's just larger than that number, 1, 2, 3, 4. Yeah. In that case, we have to. In that case, we're here, and I just have to subtract 1 from y. Is that all? I think so. Yeah, that's all. And we have 120. Oh, the ridiculousness of it. Yeah, this is fun, isn't it? So you see though, the factorial 5 is 96 plus 24. Factorial 5 is 96 plus 24. Pretty cool. Let's try factorial 10 again. Oh no, it takes a long time. It's probably it's a bit too recursive. Yeah, they kicked us out. Too much output, I think. Too much debug output. Doesn't even tell me. Oh, I need to cache it. 46, I guess. Starting to lose interest, I have to say. The final optimization isn't really interesting anymore. What if I just suppress all the debug outputs and then see if we get a result? No, yeah, I'll add a cache. Let's say you add a cache of as an array of arrays. There's a size of 50 by 50. Empty. Well, I could pass it to the function and then pass it every time again, and that would be the correct way to do it. But in this case, you know, it's just a test, it's just a stupid thing. So I think I'm just making it global. The cache cache is also a global variable here, which is absolutely horrible. So if cache x well, that y is unequals 0, and then we have it cached, and we go and just return that. No more debug output. Yeah, I don't really have to cache that, it's fast enough. Did I do that correctly? Well, now it's global, it's filled with zeros anyway, so I don't need any assignment at all. There. Well, I think that's correct. Yeah, that's the right number. So that's 10 factorial. Yeah. Now caching, of course, makes it a lot faster already, but there are other things that we can improve. To begin with, that if it is a triangle number, I might as well return the sum inverse immediately. You think I have to detect if it is a triangle number, and if it is, then what you really need to know if y is larger than n or not. Yeah, we need to know if it is a triangle number as a boolean, but also if then the sum inverse of that is, so you can compare as fast enough, I guess. But I think I just might as well return the sum inverse then. So either we return 0 or we return the sum inverse. Is that an idea? So making this an int. However, larger than was kind of silly. It's just equal to nit plus 1. Unfortunately, y is also sometimes equal to 1, but no. If y equals to 1, we just return x. So if itn is 0, then this is never going to be true. So I don't have to check that either. The y equals to sum inverse plus 1. Now we return this, and if itn is 0, because it's not a triangle number, then it's never going to be equal. And therefore we can just continue. So is triangle number now must return who's using sum, huh? Nobody. Oh yeah, sum. Sum is used by factorial. Well, that's acceptable, I guess. It's a single multiplication. Still. Sum inverse is only used Oh, so maybe it's not used at all anymore. And is squares only used here? Let's put everything inside this inside this function here. So I'm going to have a result, which by default is 0. And then we have to calculate, well, that number. Test if that is a square. Yeah, I just put is square here now around the same thing that we had before. So if m here is a square, means that the root of the m is again equal to m. Then if it is equal, then I want to return the sum inverse. So that is the square root of 8 times the result. No, wait. Huh? What? It's n again, huh? N plus 1. 1 is 1 divided by 2. Well, that's just the sum inverse formula that we have here, line 19. Applied to the argument that we pass to is triangle number. Yeah, hope I didn't mess up. So that still works, huh? Did not mess up. It's unbelievable. Now I have something that calculates the square root twice. Really? Now note that 8 times n plus 1 also appears here. And then r is the square root of that. Ta-da! So the square root here is just simply r. Methinks. Yay. Let's say again, s is 10, then the 1 plus 2 plus 3 plus 4 is 10. So if n is 4, then the sum is 10. If s is 10, then we get here 8 times 10 is 80 plus 1 is 81, which is a square. So this is true. So we get 81 minus 1 is 80 divided by 2 is 40. No, I should have gotten something else. No, it's 9. I'm an idiot. So r is 9, and 9 times 9 is 81, and this is 81 because s is 10. So that is true. So we have simply 9 minus 1 is 8 divided by 2 is 4. So yeah, that works. Let's check it again. Yep. But yeah, we still have to calculate the square root. Nah. And a multiplication for that matter. No, I don't think there's a way around it. So this whole algorithm is not really efficient. It might be more efficient if you want to calculate all the factorials. And even then, as I read here, I don't know, somewhere I read that it's never faster than just multiplying. It's just inefficient. But of course, the whole idea is that you don't multiply at all. You only do additions, right? And I saw that sometimes before, but it was really not a single multiplication. Let alone the square root. Maybe we can speed things up by generating a table with all the triangle numbers. I mean, for the factorial of 10, we only need to store, well, 10 numbers, I guess. Because you don't really need the square root, we just need to know if it's somewhere in that table. To do a binary search in the table or something like that. Yeah. Example. Sorry, the sums were 3, 6, 10, 15. Yeah, so we could generate this table, and then we could use binary search to find out if our number is one of these numbers, and if it is, then we have to just return the index basically of that array. Probably slightly faster than calculating a square root, although of course that is done on a floating point processor and might be exceptionally fast. Hell, it's the square root of an integer. It's even an assembly instruction, I think. It's just a principle. I just don't want to. I just want to have only additions. Damn it. So yeah. So really no way to make this faster. I don't think so. No, okay, well, I think we're done with this round. It's just, it was fun. Yeah, run. Factorial of 10, yay. Let's calculate the factorial of 6 and then we are done with it. 720. Yay, it works. How late is it? Yeah, let's do some Vulkan engine stuff. I had to reboot again. What? It's still not verbose. Okay. Yeah, let's crash. So what I wanted yesterday, I stopped because I couldn't think of what I wanted. Can I think of it today? The idea was to check if pipeline layout has duplicates for, let's say, when you need the same layout twice. Now, the thing is, you top. So I was working on my analysis thing. The thing is that the layout of the pipeline contains just binding numbers, not descriptor set numbers. So if you have a binding 0 being used in descriptor set 0 and a binding 0 in descriptor set 1, then the layout would theoretically make no difference between them. So the question is, what happens? I think we are really talking about the same stage as well. 1, 2, yeah. Okay, within a given stage, the same binding, different descriptor sets, the same type, everything the same. And I'm pretty sure I already have that right now. Source tests from buffers window.h. I'm having 3 descriptor sets now, and 2 descriptor sets just contain a uniform buffer. And the third descriptor set contains a uniform buffer and a combined image sampler. So at least 2 descriptor sets have the exact same. I mean, all of them use binding 0. And no, that's not true. It's not true. Yeah, well, all of them use binding 0, but the one that has both the uniform buffer and the combined image sampler uses binding 0 and 1, of course. And then the question is, is the uniform buffer at binding 0 or is it at binding 1? If it is at binding 0, then all 3 descriptor sets have a uniform buffer at binding 0. And then is the question, is my layout showing that 3 times, or is it just showing it once? Yeah, so I want to see what the result is. Simply the program as it is now. How does my pipeline layout look like? So I'm gonna look for create graphics pipeline, I guess. Well, that's great graphics pipelines with an S. Let's continue looking for the real thing. I'm GUI, also not very interesting. More I'm GUI. Is this still I'm GUI? Probably. I guess this isn't then. Yeah, no idea. I'm trying to see where, if this is possibly still the IMU thing. I don't think so, but you literally don't see any indication. We have 2 stages, it's the vertex shader and the fragment shader, but yeah, every pipeline has, at least the ones that I use. I have a debug name though. No, okay. This one is generated by Pipeline Factory. Okay, that is an indication. Yeah, IMU is not generated by Pipeline Factory. So this is one of my pipelines. I think I have 2 of them. So we are now at 82%. And here's one at 89%. And then we go back to the top. Okay. Now the only thing that we have here for layout is a handle. So this is a handle. 62 5F, I can't remember that. And the other one is the same. Very efficient. They are probably very much the same, yeah. So definitely the layout is the same. So let's have a look where that handle comes from then. Layout with handle, created objects, created object and pipeline layout 0 with handle and type pipeline layout. And then we found it in the cache, so that's why it is being reused. And then we use it to create a pipeline here, and this is also constructing a pipeline, passing the layout, and then for the second one as well. And that is 91%. Even the pipeline appears, the layout appears here when the pipeline is being passed to whatever synchronous window. This is, we are at the top again, so this is where that was just created. Well, we have to be able to scroll up then and see where that happened. I think here. It's very dark, sorry, it's just a nasty color by coincidence. Well, let's read it. Sorted bindings and flags. Sorted bindings. Binding 0 is a uniform buffer. It's not an array, and it is used by stage the vertex shader, stage, whatever. And we never do that. Binding flags also not. Descriptor set layout flags, don't have that. It's not unbounded. And we have the suggestion to put it in set index 1. There's a handle here. M handle. What the hell? So the binding flags. There's another one. That looks like a duplication, doesn't it? Yeah, cool man. Yeah, of course. I did not do any boundary checking. So if you go too large, then you just overflow stuff. I have a cache. My cache is 50, which is a little bit larger than 46, which was needed for the factorial of 10. So if you make that cache a lot larger, then it takes uses a lot more memory, and then you can go a little bit higher, which is not much. I don't. It was just for fun. But you probably overload the cache. Overflow the cache, I mean. Challenge for you. Make it work for larger numbers. I'm seeing definitely 3 binding zeros here, and they look very much the same, don't they? Uniform buffer, script account 1, script account 1, stage flags vertex, immutable sampler 0, immutable sampler 0. Binding flags, nothing. Descriptor set layout flags. Set index hint 2. Okay, that might be. But still, I mean, there is a difference, but that's hardly a real difference. M handle, this is a handle, that is, nobody knows what it is. Okay, and then we get again, I guess, just a third time. Sort the binding and flags. Oh no, we have a binding one. Okay, that's a combined image sample is put there. Script account. Again a binding 0. Holy big comment. Yeah, my memory is non-existent. So it's all new. That's why I write the comments, because otherwise I just wouldn't know this anymore. Let's realize the handle is initialized as the handle of a descriptor set layout that is created from imported bindings. I call to a logical device realize scriptor set layout. The first call could pass a vector with two elements. The first element having two elements and the second element having one element of its own. Realize the descriptor set layouts. Element 0, sorted bindings, binding 1, uniform buffer, binding 0, combined image sampler. Element 2, binding 0, uniform buffer. But now a second call passes a vector with layout sets that are considered equal and only looking at the contents of the sorted bindings, but use different values for mset index hint and binding. For example, now we have the uniform buffer at binding 0 and the combined image sample at binding 1. The rest they are the same. And then this means that the same pipeline layout can be used and is returned, but the requested set index and binding hints must be changed. In both cases, yeah. But I still have a memory, and I think that that is not true anymore. I don't think I can map bindings. And that mapping is returned in the set index hint map. Yeah, that just maps a set index hint to a set index, which has nothing to do with the binding. I cannot remember it anymore that I even wrote this. Well, very, very vaguely. But no. This is the type that I want to check for duplicates though. No, it isn't. That was VK, this one. That has the binding number. It does change the bindings. Mm-hmm. No, it looks like it is true. Bindings are changed as well. Yeah, I never use abbreviations unless I write some a one-page test thing for fun. But at the end, it was standing for is a triangle number, and then later I changed it from a boolean to returning the inverse of the sum function that belongs to it. So basically, the index of the triangle number. So if you change the I from is to index, then hey, but I added a comment. You can change the ITN to index triangle number in full. That would work. Or maybe triangle number index, TNI. It's pretty weird, isn't it? I mean, the underscore R here, this underscore here, means read only. Yet I'm changing it. Set layout in is read only begin. It cannot change whatever this is pointing to. And then we get that, and then we can change that. Why? How? So the reason for that is that sorted bindings is returning a reference, so I can change it. But I would only do that if it's not const. So we need a non-const object to call the sorted bindings on. And sorted bindings on flags, same thing. Would only return a non-const reference if you call it on a non-const object. But the object that we call it on is set layout in, which gets its whatever the type is from a call to begin on descriptor layout underscore r. I guess that's a vector. That should return a const iterator. So I'm not even understanding how this compiles. Unless binding itself is declared as immutable. But I start all my members with underscore m. So I suppose that this is a Vulkan member. Well, yeah, like that one. But is it the C API? Should probably this one or something. This one, even more likely. Descriptor set layout binding. So I think that binding in is an iterator to something containing a descriptor set layout binding. Which was it? Descriptor set layout binding, yeah. So it doesn't make any sense whatsoever. Why this is compiling? Underscore R, really? How? What? I don't get it. This is a read access type. Should be difference between the two. So it's a read access type of something with AI thread safe policy primitive. Primitive has a read access type. Oh, the read access and the write access type are exactly the same. You gotta be kidding me. What? Well, that's not good. Don't like that at all. So now my code looks like it is only read access, but it compiles even though I'm changing it because the type is the same as the write access type. Now, of course, theoretically that is the case because it's just a normal mutex. Meaning that, well, you lock the mutex or you don't. And if you lock the mutex, then you lock out all readers as well, because you lock the mutex. Therefore, you might as well have write access. From that point of view, there's no difference. But yeah, I was always like, I don't know. Maybe I want to make a new type. Access const is not convertible to write access type, I think. So if you're referencing a thread safe object that is const, then you're not allowed to change it ever. So then you get this thing, and then you get a const pointer or a const reference, so you really cannot change it. And I think that also should be the case if we have a red type, even though that is convertible to a write access type. So how would that work? So this makes a difference. We have read access and we have write access. Now, if you have write access, then you also have read access. So it's very easy to convert a write access to a read access. The reason being that write access simply is a read access. Isn't it? Yeah. Write access is derived from read access. So if you have a write access, you also have a read access. But not the other way around. So if we want to create write access from a read access, now we have to do something. Well, that is not the case if you just, this is a read-write lock. If you have a simple mutex, then that's not the case. But might be important to make a difference, I think. Anyway, I just like to keep track of constants. So we have the const thing, and then we have an access. And maybe I should split up this access into two parts. One for, well, the access that we have, read and write. And one that is really read only. But yeah, on the other hand, I mean, suppose I do that and I have a red type, a read access type, and then I think that, you know, okay, so that gives me read only access, and then I convert it to write access type somewhere deep down in the function because I want it. At that point, there's nothing to check. It's just a static cast. You just cast it to an access and that's it. So really safe is it's not really safe. I mean, you still don't know if later on it's not being changed. Cool man, I named them .h. But yeah. Not because it is better, I think. So not to say for .hpp. Yeah, all my headers are C++ anyway, so I don't have any C headers. I don't write C anymore. Shall I do it or not? I'm trying to think of a reason that it would be stupid to change this. I would make, let's say, all the RAT, the read access types would turn into basically const pointers. And then I want to get a write log, and then they turn into non-const pointers. However, I already have the write log, so I would just do something that is equivalent to a const cast, going from read to write. Yeah, it's maybe that's exactly what I should do. Demand that you use a const cast, and then at least you're aware of what you're doing, which is better than what I have now. Accidentally deep down writing to a read access type. It's simply not correct. So I think I should do it, but then the conversion from a read access type to a write access type should be hard, let's say, or hard. I mean, you have to type const cast, I think. How can I make that work? Okay, I think that's possible because these things are const, right? So I might as well always have a const object and then only allow construction from non-const read access types. But then you just have to add a const class to make that work. Now I need to think of a name because I already use read access and write access. I think I'm gonna call it const access as opposed to access const. So let's make a copy of this, duplicate it, call this read log object. Not. Text log object. That provides read access. I'm calling it const access. And that then returns a const pointer and a const reference. So now we have only read access. Now the access object should still be both. So I must be able to pass these two functions that take, say, a const access object. So it must be a const access. That's no problem. Which then means that this oops. So const access it's just the header, the base class, and that means that we need perfect forwarding. Well, that's what we do here. Wrapper, blah blah blah, perfect forwarding to the base class. Okay, that should work. So I don't think I make any change now. I just inserted the base class here. For the rest, everything is the same, right? So this should still compile. Ah, it does. That's cool. And then the next step is that I want to be able to construct an access type from const access type. So we'll construct an access from a const access. Let's have a look at right access. That's pretty close, I think. So here, promote is called promote. Okay, so promote the read access to write access is explicit, and we just pass a reference to it. And also here, and you see it's non-const. That's nice. Oops, undo, redo, promote. Read access to write, well, whatever. The comment, I'm happy with that comment. And then still explicit. Yeah, we don't have wrappers, we don't have anything on that. We now have a const access wrapper reference. I have to peek again. It's the right access. It's called access. So the wrapper, we have the wrapper stored somewhere. I mean, this one says access.m wrapper, but that's maybe different. It is a different object. So do we also have the wrapper stored here? Well, the wrapper is being passed to const access, which is being passed to access const. And access const is storing it in m wrapper. Protected. So yeah, we can access it in the same way. And it's a pointer, so after the dereference I get a normal reference. And the wrapper, the const access thing here takes a wrapper reference. So just a non-const pointer here, so dereference gives me a non-constant reference. So this code is correct here. But then what to pass here? Let's go with that when to. Normally, if we construct it directly, we just pass all the other arguments to, well, currently here, which is then passed to that base class, which is this one. Which is passing it to the wrapper. No, wrappers, and in the end is wrappers a wrapper. So it's just being passed to the type of the wrapper. Yeah, so there's just constructor arguments. I don't need those again. I don't need them again at all. Hi Zaz, yeah, same thing. Well, I mean, it used to be class, I think, but yeah, you can also pass int, and int is not a class. But I think it accepts the same thing, so it doesn't make a difference for the rest. So you could do class T and then pass an int anyway. I think. I'm not sure because I always use type name for that reason. Then at least I cover everything. For real. Mm-hmm. Still much the same like this one, right? Or not? Just. I don't think I want to construct a new object. Or do I? See, this x as const does not have anything. It already has this, by the way. I don't need to repeat that. It only has a wrapper pointer. It's the only thing. Yeah, okay. I'm getting it. We cannot do that. If we would make a, let's say, if we would make a write access type from a read access type, as in constructing a new object, then I would have two objects that have access to my mutex locked thing. And then when you destruct one of them, yeah, then I would have to introduce a reference count for that. That's ridiculous. I'm not wanting and going to do that. In other words, only one of them can cause, let's say, the destruction. Call unlock. Well, the last one anyway. But which one is that? No. Undo. Where are we? This is not possible. Cannot do that. Well, we want to be able to do something like it. So I should be able to cast it. Say I want to cast the const access to a normal access. Now this one is derived from that one, but maybe I can define a forward declaration here. Because, yeah, the only thing I need is a reference now to it. And then I want to be able to do an explicit cast to this type from here. So we have explicit. And I think I think that works, explicit, yeah. And then operator, and then this type. And then the only thing we should be able to get, I think, is a reference. Or am I mistaking now? Because I also want to... const reference is usually enough. It is enough, isn't it? Const reference. Something is wrong here. Maybe like that. You cannot do that here. You cannot do that here. Let's see if this compiles, because I'm not even sure. So we declare this one up front in line. And then now we can explicitly cast the const access to normal access. And then I want that requires const cast, right? So this member function is not const. Let me add a comment. This is a non-const member function in order to force the use of const cast. And then we have to define that as soon as you know what access is, which is here. So that is a member function of const access now. Explicit is, well, we don't need to repeat those things. That is a member function of const access. Do I need to specify the type here? I don't think so. I mean, the return type of an operator type is just that type, right? So this is also the return type. So now we should be able to do a static cast, because now we know that const access is the base class of access. I'm not sure if I should use a const here though. Probably doesn't make much sense. Might as well remove that. This is not const, so it amazes me too that it keeps compiling, by the way. So that was the conversion, and now I want to change my read access type into this new class. And then some, at least one thing should stop compiling. Hopefully not a lot. It's defined by wrapper. Access types, so you need an overload of access type of, well, whatever. I'm just going to look for a read access type. Primitive, I guess this is the one then, right? Yeah, that's the place. So I have another one here for one thread. And this is for read write, and that's all, yeah. So then the trick is we're going to use here const access, and I'm always making that const. And that last constant forces us to use const cast to cast it away if we want to go to an access type. And now all hell will break loose. Please don't be too much. Cannot assign to return value because function operator there returns a const value. But this is an underscore W. What? Oh yeah, I'm using a read access type and I'm calling it underscore W. So now, because I made this a real read access type, you can no longer use it to write something. Then why is it a red? I am very confused here. The move constructor can only be called as a result of a reallocation. As a result of a size increase of the standard vector worker, because workers are put into it with and placed back. Worker is not copyable and we never move worker out of the vector. That means that at the moment the move constructor is called, you have the exclusive write lock on the vector, and therefore no other thread can access this worker. It is therefore safe to simply copy and quit. And then I'm getting a write access to mquit and a read access on the r value mquit. R value is, if I have no idea why I would not just lock that also with the write access type. This argument, remember function get and use color as type const. It's another bug. So I'm taking a read access type here and then call get and use color. But get and use color is non-const. And it is non-const because mNext color is being assigned. Next color. Klik read log on mcolor pool. Like the only variable that it has. Next color. Get color and then it's const with use color and get and use color not. There is use call defined. Right, so a history. Do I also have a history? Oh, I have a history here. Yeah, well, I mean, it's gonna compile if I make it a write log, so why not? So why not? Cannot assign a return value because function operator data returns a const value. Oh, it's again. I'm seeing the underscore W, and I'm amazed how often I did that apparently. Because this error is gonna be because it is a red type and not a right access type. I bet. Yep, yeah, red. Yeah, well, if you call it W, then use W. Come on. So take a right access type. And this is read only. And then, yeah, we assign to it here. I don't know. No missing member function for call to insert. Yeah, you cannot insert in an read-only type. Kind of strange that I would use red here at all then. But I'm glad I made this change, because you know that's really confusing. You see this and you think, okay, so it's not changed. Of course, here I only need to read. I only need a read access here. I only do the size. Get a size, but yeah, I mean that's definitely right access. And that's why I did it, because I was confused that binding in was changed, if you remember that. And now we detect that this is the case. So I'm going to comment this out for now and see if we have any other errors. And if not, then I can finally concentrate on that one. This argument to member function unlock has type red, but function not marked const. I want to be able to call unlock, I think, on my red type. Of course I want it. It's experimental anyway, so we can do unlock. Hey, Mr. Lil. You know what? The first one who said anything about your nick was Post Bunny. And I thought, well, maybe. But then you said it yourself, and now really I cannot see anything else anymore. So yeah, I don't know. Yeah, you had it when it was still true. Back when it was still true. I'm just kidding. Rhetorical question. Well, not even rhetorical. Well, I won't bother you anymore. I thought you were serious, so I was trying to help you to get past that barrier. But if you want to keep it, that's fine by me, of course. So don't feel pressured. So when I was a volunteer in this institution of highly gifted school dropouts, there was a kid who was calling himself I cannot remember it exactly anymore, but something like, let's say, Acid King or something like that. Something with acid in it. So some, you know, a very strong drug. And his problem was that, I mean, he said he never used drugs, which I believe. And he just, when he was really young, he just thought it was cool. And then that was his name. And then he became a moderator on Reddit. And people feared him because, you know, moderators, people fear moderators. And he's so well known that if he said anything to people, you know, they were always by like bo and yes sir, and you know, afraid to be banned. So he could just, you know, be a moderator and tell people, you know, hey, come on, don't say that, don't do that, and they would be like polite and stop doing it. And he noticed that if he changed his nick, people would not recognize him anymore, and he would not have the same authority. But now he came at the age that he had to solicitate for a job. And I told him, that is not a good name to use on your social media if you want to get a job. So yeah, it gave him a lot of trouble. So then he came with the story about, that if he changed his nick, that then people didn't respect him anymore. But I think half a year later or something like that, he told me that he changed his nick. So that was a good thing. And he did get a job. He's very good with computers. He had no what is it? No diploma, of course. I mean, dropped out of school and stuff. But that doesn't mean much, right? I mean, well, it meant something, but not if you're good with computers or not. So he did get a job as some technical, I think on a help desk or something. I think he was overqualified for that, but yeah, you got to start somewhere, right? He's 18, so he knew much more about computers than I did. Well, maybe not programming, but definitely running hardware and stuff. He was like the sysadmin in the institution as well. Got access to all the servers and everything. Kept the whole thing running. Yeah, it was one of the first things I told those kids, when we started, and I said, I think that privacy means the right to keep your social circles separate, which means that you don't have that right, when it comes to the government. They just know everything. Google probably knows everything. But they are not really part of your social circle. And for example, the fact that they were in that institution was a social circle. But if a year later they would leave that institution and they would go to a volleyball club, then you just want to be among peers and not have people look you up on the internet by your real name that they know, and then find out that they have gone to that institution and were, what is the name, oddball in society, school dropouts, etc. Or say, a logical example, if you're questioning your sexuality and you want to online find out what it is about, and if it matches your feelings and stuff, you have to be able to do that without that everyone at school knows. So you don't use the same name, on the internet as you do at school. So real life, everything real life is per definition, almost per definition, a different social circle than what you do on the internet, I would say. With the exception, of course, when you are required to do something on the internet by a real life club. So if your school says you must log in there on the internet to get your homework or whatever, then you make a new name, or you name. Yeah, I would not use your real name on the internet, period. So I would make some new name, definitely a new email address, and I use that email address exclusively for the school, for that school thing. And don't use that email address anywhere else. This is what I have done from the beginning, and I have been on the internet from the beginning of the internet. So call me smart, I don't know. Carlo Hood is my pseudonym for C++ coder. And I have been very sloppy lately. I mean, you have been seeing lots of my Arab pseudonyms pass by during the stream. By now I'm like, I don't care that much anymore. But I also don't need to get a job, you know. And of course, those kids told me, yeah, well, that's a bit too late for that. They had already been using the real name on every social platform and posting pictures that now they could not delete anymore. I mean, if you're a teenager and you get drunk and you start dancing on the table half undressed and you post it on social media, then 5 years later that can bite you. If you, I don't know if people if you go solicited for a job, then maybe they don't try very hard to dig into your teenage life, but it's still online. So I don't know. I would say keep things separate. You know, different email addresses. You can just use different Gmail addresses. It's good enough. I trust Google not to mess those things up in the sense that you know they actually publish it. They know which email addresses all belong to me, but that doesn't mean that other people know or can find out. Yeah, it's I understand, man, because it is you know, every name you use grows on you. You know, it becomes a part of your identity, and then if you're proud of it, of course, and it's part of you, and then you go to a different, completely new, semi-anonymous social circle on the internet, then it is extremely tempting to use the same name. But yeah, that does mean that you throw everything who you are on the internet in that new group as well. They can immediately search for you and know loads of things about you. Which makes me think about what things that I read about the darknet, people who do really illegal things. They're usually caught by that fact. Like, say someone is really bad and the FBI is trying to find them, then it's a matter of having accidentally used a name that they only one time mentioned somewhere else, and you know, and that's then the way they find it. They find such guys. I don't think the way internet works at the moment is good. I don't think it's good. It's almost impossible to do what I just said. You know, keep your social circles separated. Because it's so difficult, people just don't do it. Period. Yeah, I want to finish this, I guess. Cannot assign to non-static data. Member. Did you already do that? Oh, I made a const and I cannot assign. Ooh. Yeah, Going to need a const cast here, I'm afraid. Two const casts on one line. And mref is from well, anyway, mref is probably also not allowed to be changed here. It's another one that I need, and then we have here log is probably in. Is log const? No, log is never const. Okay, too annoying. Let's change that back. And this as well. Little dig, no. I never drink energy drinks. Energy drinks. Never. Considered poison. All sugar is poison. So the idea to drink something... and plus, it's not just a lot of sugar and calories. It's the caffeine, yeah. I never drank even one single energy drink. Ever. I have not drank coffee for a very long time because I thought that my parents, I told that story before, we were driving home from Switzerland in one day and they couldn't even drive home the last 100 kilometers. They had to go off the highway to drink coffee. And I was a kid and I sat in the back and I was thinking, well, then you are addicted, right? If you just, what the fuck, we could just drive home. And then I decided never to drink coffee because I don't like to become addicted. And then when I was at least in my 40s, I played chess for a long time, and at some point I had to play for an external game, so for the team, you know, and it's not just for you, it's for the team. And I had slept very badly and I was sleepy and I had to play a chess game in real life. And then I decided to drink a cup of coffee. Exclusively to wake me up. In order to make more chance to win the game. And then ever since, I drink coffee on the chess club. So once a week. Well, not every week. I mean, I like tea as well. But especially on tournaments or something like that, I was drinking coffee purely for the caffeine, I guess. And then, you know, yeah, at some point I started to drink 1 cup of coffee per week. Maybe even 2 sometimes. But never at home. I don't have a coffee stuff at home. So only when I go to the club or when someone came to visit me and we went out, we would go sit somewhere to drink coffee on the terrace or something like that. But yeah, just like I said, 1 cup per week of coffee. That's not addicted yet. It's probably not even unhealthy. By the way, and I know that because I drink so little coffee, if you drink a cup of coffee and then you go to the toilet to pee it out, you can smell the coffee. You can smell the coffee at least. Sorry, not coffee, but the coffee. For a long time, I was smelling something and I thought, you know, like bacteria. What the hell is wrong with my urine? But at some point I recognized it. It's just coffee smell. It's unbelievable. Most people who drink coffee drink every day coffee, maybe even twice a day, so they don't know the difference. But it's really, it smells when you pee. I mean, isn't that like proof that it is a bad thing, coffee? Something in your body is working very hard to get it out again. As you can see, I'm getting tired again because I'm not making progress. Const cast from const AI thread save const access blah 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 to is not allowed. Because I also changed the type. Well, it seems to compile. That wasn't that bad. It's only a handful of problems. And that one, of course. Yeah, well, now the question is, do I want to pass a right access type just because I changed the binding numbers? And then only if we find it in the cache. I guess I should, because, well, it's never a good reason not to do it, really. Oh, let's just change it to what? Who cares? Although, well, anyway, yeah, well, this one, right? Yeah. Substitute that with W. Or not. Binding in came from layout in, which comes from the underscore W now. Okay. So this should be sufficient. A realized pipeline layout. So then this must become a W. That's just being used in this one. See that it is kind of annoying that I'm using W here, and then you start thinking, oh, where is he writing? I'm writing all the way down here, and even then, I'm just passing it. I'm then tempted to say, okay, I'm using. Oh, I have to test it anyway. Let's just do it just because I have to test it. So we keep red here, and then here I have to pass a W. So now I'm wanting to attempt my cast. So this takes a const reference at the moment, which means that if I have a reference, then I can pass it. Yeah, but I don't have a what reference, so this should not compile. Let me try that. That better not compiles. What kind of error is that? No viable conversion from RAT to what? Yay, that's clear enough. Okay. And then I can try a static cast, which should also not work. And I'm going to cast it to a what? I think, right? Going to cast it to a const reference. So. No, it should also not compile. I'm just wondering what now the error is. It bloody compiles. Why? The static cast just thinks yeah, this is the base class of that type, so you can just do a static cast. What is annoying? Well, it's still a cast. It's almost the same as a const cast, right? I mean, I see that I have to do it. Now, if I needed that would be different, right? Undo. There we go. This won't compile because that thing is const. So you cannot cast it to a non-const reference. But yeah, it doesn't help much. I mean, then I could force myself to need a right access type reference if I change the signature of this function. But the function itself doesn't know that I want to pass a read access type sometimes, so it doesn't see any reason to want to use a what reference. So not another way that I can forbid this static cast? Don't think so. Well, I could make it I could make a wrapper around it, maybe. Nah, I think I'm going to be happy with the static cast. So I would be more happy if this had to be a const cast, like const cast and then cast read access type to write access type. That would be ideal. But in order to forbid this, but not the conversion backwards, maybe I need to make it a completely different class. Yeah, why not? Why not? Make it a completely different object. I can still allow conversion from a what to a red. I think. So now the const access is the read access type, and I can just static cast it to the access type. And I don't want to allow that, but I do want to allow passing an access type to a function that takes the const access, but not the static cast back. I must look at the stock market, sorry. I think I'm gonna stop streaming. I mean, I don't like this, you know. And then having to work around that. But it seemed to have worked before, without actually dumping private stuff. Nope. Not good. What the hell? Yeah, nah, not happy. Everything went down again. What the fuck, dude? Oh shit. I'm just too lazy to keep an eye on it. That's what is the problem. I'm really too lazy here. I should have sold there. Now it's here, which cost me... yeah, 300 euros. If you look at it that way, then the streaming is pretty expensive. But yeah, it's not just the streaming, it's just that I don't want to look at the graphs the whole day long. There. Like 2 days ago, I had like a €1,000 loss because yeah, because I did something that if I had not done it, and then I would not have had a €1,000 loss. And today, everything, you know, completely, my losses were completely wiped out. I had €1,000 gain even. So that was a good thing. And then you think, yeah, if that can happen in a single day, you know, maybe I should just sell. And maybe tomorrow, or well, Monday, it's going to be minus 1,000 again. Which means that I will be 2,000 in the plus if I sell it. But I didn't sell, of course. Because every time it goes up, you think, oh, maybe it's the beginning of a rally. I don't know. And maybe it is. I hate this stuff. I don't know. A few months ago, I could predict everything. I just felt like it's gonna do that, and then it did. So, and since at least a month or two, or longer, I have absolutely no clue. It's so random. It's so bloody random. Up and down and up and down. I have no idea where it comes from or what it's going to do. Very annoying. Yeah, just went down. But this one. I think I should just sell it, but you know. I was going to look at the stock market when the American stock market opened, which was several hours ago, and I didn't do it. I was streaming. €300 because I was streaming. I'm pissed off. I think I'm gonna stop streaming anyway, because I'm gonna eat something. I'll not be online tomorrow and not on Sunday, so not the whole weekend. Maybe tonight though, this evening. Maybe even earlier though. Probably this evening.